Okay, class. So welcome to today's lesson. We're going to focus today on the number system, and that's going to take us into radicals. So our number system, here's a good diagram to kind of explain what it is. Big picture, small picture. We have what we call our real number system. Okay, it involves everything inside this box. For the real number system, we have what we call rational numbers. And I'm going to explain what those are up above. Our rational numbers are different than what we have as irrational numbers. This year it's different. We're going to learn about irrational numbers. You haven't seen an irrational, well, you've seen it, but you haven't known that it's not rational and that it is irrational numbers. Okay, real quick definition of what is an irrational number. Well, an irrational number, that's the quick definition is you can't make it a fraction. Oh man, you can't make it a fraction. Can't make it a fraction. So the fraction is often explained as A over B. Now, on top of that, because you can't make a fraction, what it means is that the decimal continues forever, and it does not repeat, and doesn't doesn't repeat. And the ones that you know, or that you've seen before, are things like root 2, root 3, root 5, root 6. Those are all irrational numbers. When you try them on your calculator, for instance, if I go square root 2, it goes forever. It continues and continues and continues. It doesn't repeat. Root 4, on the other hand, stops. So it's rational. Root 5, irrational. Root 6, irrational. Root 3, irrational. Root 8, irrational. What about 9? It stops. Okay. So for a rational number, what we have here is you can make a fraction. A over B, where B does not equal 0, because anything with 0 in the denominator is not really a fraction. So what all is included in a rational number then? A rational number is our natural numbers, okay, our natural numbers, our whole numbers, and our integers. Those are all different forms of rational numbers. So let's explain each one a little bit more. So a natural number, those were our counting numbers. Okay, counting numbers, but that it excluded 0. So that's kind of like caveman. He didn't understand you could have nothing of something. He wasn't very smart. So he started at 1, 2, 3, 4. So examples will be 1, 2, 3, 4. And then this means it continues. Okay? So the pattern continues. Whereas whole numbers are exactly the same, but now it included 0. So it would be natural plus and 0. And so the example will be 0, 1, 2, 3, 4, dot, dot, dot. So the dot, dot, dot means that it continues. Now integers are positive and negative whole numbers. Okay, so for example, -3, -2, -1, comma 0, 1, comma 2, and it continues in this pattern on the positive side as well as continues in the pattern on the negative side. Okay, now remember, integers are whole, whereas rational numbers includes basically everything. Any number you know is going to be rational. So a rational number, basically the definition is it can be a fraction. Okay, now what that means as a fraction is that it's the decimal stops or repeats. So some examples of rational number would be like negative 1.3. Okay, that is not an integer, but is a rational number. Negative 2, that is a rational number. Things like 4.7, that is a rational number. You can make it a fraction. So this is a fraction, it would be negative 13 over 10. You saw that last year in grade 9. Negative 2 over 1. 4 7/10, or 47 over 10, your choice. Something like 8 as a fraction, 8 is 8 over 1. Okay, so those are all rational numbers. Some weird ones are things like 1/3, because that equals 0.3 with the repeat bar. 2/3, that equals 0.6 with the repeat bar. Okay, but because the fraction is repeating, it is rational. Irrational numbers, you can't make a fraction. So that's going to be something like not or unperfect. What's the proper word? Imperfect roots. So for example, square root 3, square root 5, pi is also an irrational number. Compare that to something like square root 4, square root 9, square root 16, square root 25. Okay, an irrational number would be something like square root 10. It goes forever on your calculator. 10 goes forever. Okay, whereas something like root 4, well, what does root 4 equal? Well, root 4 equals 2, which equals 2 over 1 is a fraction. So that's why root 4 is a rational number. You can do the exact same thing with root 9. Okay, what is root 9 as a fraction? Well, let's simplify it. Root 9 is 3, which equals 3 over 1. Okay, so irrational numbers, you cannot do that. You can't make them into a fraction. Real numbers, those are both rational and irrational. Okay, you're not going to see imaginary numbers until, well, they'll talk about next year, but you won't do anything with them, not until you hit university to do something with them. Okay, so there's our number system. Any more help, let me know. What some other examples of rational numbers would be, 3, 7 over 8. So try that one in your calculator, 7 divided by 8. Oh, that one stops. What about 8/9? That one goes forever. Your calculator is rounding the last number, but it's 0.8 repeating. Okay, those are all rational numbers. Something like negative 2.4. Okay, you can make that into a fraction. So let's go down here and categorize as rational or irrational. Remember what these 3 dots means? It means that the pattern repeats. Okay, so the pattern repeats forever. So another way to write this as negative 5.15 with the repeat bar over the 1 and the 5. Okay, and because it's repeating, it is definitely an R. It is a rational number. Okay. Now, if you look at the next one, guess what? What's the next one? It would be 1, 3, 3, 3, 3, 3. So again, the pattern repeats. Okay. Sorry, the pattern continues. Better word. The pattern continues. So this one's not a repeating, so it is irrational. Okay. Whereas this here, root 3 over 2, because this is not a perfect root, which we looked at yesterday, not a perfect root, therefore it's going to be irrational. So we can go to our calculator and simplify it. Root 3 divided by 2 goes forever. There's no repeating. Okay, it just goes forever. So it absolutely is irrational. And I knew that because root 3 isn't rational. If I had root 4 over 2, that would be 2 over 2, which equals 1. So this here would then be rational. Okay, good. This one here, 2.4747. So again, it continues. So you can rewrite this as 2.147 with the repeat bar over the 4 and the 7. It is a rational number. It will make a fraction. I don't know what it is, but I know it'll make a fraction because the 4 and the 7 are repeating. Okay, so because it's repeating, then it is rational. Here, looks being complicated. Turn that into a improper fraction. So 2 times 4 equals 8 plus the 1. We get 9 over 4. Last year you looked at that. You can square root the 9 and square root the 4, which is 3 over 2. It's a fraction. So this one definitely is rational. And the last one here, root 200. Well, try it on your calculator, see what happens. 200 square root, it's not perfect. It's not like Mr. Barker, so it's definitely irrational, okay? Because it's not perfect. Only perfect things like myself are rational. Okay, so classifying numbers and your number system can be a little murky with so many different examples, but let me know if you have any questions and I'll definitely go over it with you. Introduction to radicals. So what is a radical? A radical is anything with a root sign. Okay, so that is a radical. And so we have on a radical, we have our index right here in that location. It fits inside the check mark. Calculators write it up front. That is not good. All right, it must go inside the check mark. So don't be like a calculator. All right, that's your index, and this here, this number inside is called your radicand. Radicand. And radicals can be rational if they are perfect roots. Such things as like root 64, which equals 8, maybe root 49, which equals 7, a whole bunch of different things, or irrational if they are not perfect. So if they're not like Mr. Barker, then they are irrational. So for example, square root 21, square root 48, those are all not perfect roots. So how do you know a radical will be rational? Is it perfect? Okay, so two things. Number one, you can use the factor ladder / division that we looked at the last couple days, or you can check on the calculator. Okay, so if I say prove it, guess what? You're doing the old factor ladder division. Okay, so before we begin with evaluating the following, there's two things that I just remembered that we need to look at, okay? So, first of all, what you gotta be careful of when you're writing radicals is that the roof, okay, 3 times 5 times 8, okay, the root times 9, okay? The roof, I'll use that in quotation marks, the roof must cover the entire radicand. Okay, that's kind of a rule we got to focus on, making sure we write it properly. This will be 3 times 5 times 8 times 9. This would be not inside, okay? And that's what we got to watch out for, is that times 9 would not be inside. The second thing we have to be careful of is that the index must be inside. In other words, if we have 3, it's got to be in that location, not 3. Okay, this would be new. Don't want that. Okay, so we've got to make sure that your index is inside in the proper position. So index should be inside, and that's what we have here. And by inside, I mean kind of within this little area between those two lines. Your calculator does a horrible job of this, which is why it messes you guys up. Okay, so if you have your index outside like this, that is not the proper space to put it. No, we don't want our index in that location. Okay, so it's going to be a little bit of review of yesterday. Evaluate the following radicals. So here your index is 2. We're looking for 2 of the same numbers. And so for us, that would be 5 times 5. Therefore, it equals 5. Cube root of 8, we're looking for 3 of the same numbers. And you could guess and check. Okay, and for us, that would be, whoops, pardon me, I screwed that up. It's 3 of the same numbers, but the number is 2. And so that equals 2. Now here we're looking for 5 of the same numbers. That's going to be a trick. So my guess is you want to start doing your hook and ladder and go divide by 5. Go to the calculator, 3125, divide by 5. It's 125. Divide by 5 is 25. Divide by 5 is 5, and I screwed something up. 3125 divided by 5 equals 625. There we go. 625 divided by 5. 125 divided by 5 is 25. Divided by 5 is 5. So the fifth root equals 5 times 5 times 5 times 5 times 5. Therefore, it equals 5. Okay. Good. Going on then, 3600 square root. So here we have 2 zeros. When you're dealing with this, this equals square root 60 times 60. Okay, so really what did I do? I just basically, because we had the even numbers, I took the square root of that as 6, and then I added in a 0. Okay, so the square root is simply 60. Now we're doing with decimals, so if you have 2 decimal places, then that's the same as 0.9 times 0.9, which equals 0.9. Okay. Here we have 4, so this will be square root of 7, and then I'm going to have to add a 0 in there for that. And so this equals square root 0.07 times 0.07, which equals 0.07. Now those were even, all right, even place values, in the sense that here we had 4 place values, 2 place values, 4 place values. But it doesn't go the same if you have odd number of place values. So square root 0.049, go to your calculator. Guess what? It ain't the same. So this does not equal 0.7 or anything like that. All right, this is not equal a rational number. It's not perfect. So your place value is important. We're looking for even place values. Cube root of negative 64, well, that's going to be a negative number. Negative 8 times negative 8 times negative 8. And so that equals negative 8. But what about the fourth root? The fourth root of negative 64, it equals undefined. Okay, null set, or does not exist, DNE, because there's no four numbers that are negative multiplying together to equal a positive. All right, that just does not happen. Sorry, four numbers multiplied together to equal a negative. Okay, it would equal a positive. So it can't happen, it can't exist. But 6th root of 64, that can work out. So you divide by 2, 32, divide by 2, 16, divide by 2, 8, divide by 2, 4, divide by 2, 2. So how many are you looking at? 6 of them. 3, 4, 5, 6. So that equals simply 2 as a value. Now, let's expand that out. So we're going to take that inside exponent and go 9 times 9 times 9, and you can see that equals 9. So your exponent and your root, okay, the exponent cancels the root. Okay, the exponent of 3 cancels the root of 3. So you can mess around with some numbers there. Okay, here these are honors. We're not ever going to look at those. You'll never see those. All right, good. Fourth root of that, 1, 2, 3, 4. So it's an even number. So that can break down into fourth root of 81. Divide by 3, 27. Divide by 3, 9. Divide by 3, 3. So I would go 3 times 3 times 3 times 3. And how many zeros do I need? Well, I just need 1. And so that equals 30. So I take these and spread them out with all 4. Okay, estimating on a number line. So a couple things you need to keep in mind. Number one, you cannot compare these two easily because we have to move that 2 inside. All right. So what we can do is we can compare root 81 versus root 80. This will be larger. So then the whole thing will be larger. Okay. So you're going to look at the radicand to compare them, but you can't compare root 81 to cube root 62. You don't know what they are. You'd have to find the roots. Okay, so what we're going to do then is just move this down here to the side. Good. And so let's go here. 2, we're going to move that inside. So we would get 2 times 2 times 8, which is square root 4 times 8, which is square root 32. So if we're comparing that to C, which is root 32, they're going to be equal. Okay. So whereabouts is root 32? Well, let's have a look here. We know the perfect square above and the perfect square below. So if we get the perfect square above from last year, we looked at this. Perfect square above would be 36, which is 6, and 25 is below then, is 5. So here we're only 4 we're only 4 digits away, and here we are 7 digits away. So then we're going to be looking at like 5.7, something like that. Okay, the fourth root of 6, whereabouts is that? Well, if we have fourth root of 6, the fourth root of, say, 1 equals 1. So if we have 2, 2 times 2 times 2 times 2, we'd be looking at the fourth root of 8. And so this thing's going to be something like 1.6. Okay. Cube root of 30. So let's see. Cube root of 1 would be 1. So then 2 would be 2 times 2 is 4 times 2 is 8. So this isn't 8, my bad. I got to back up there. Shame, Mr. Barker. If this is a 2, 2 times 2 is 4. Okay. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So this is going to be a lot closer. So we're probably looking at 1.3 maybe, something like that. Okay. Excuse my poor multiplication skills. So this here would be cube root of 8. So we got to be going higher. So let's say this is cube root of 8, which equals 2. This would be a 3. 3 times 3 times 3 is 27. So we're still below. So this should be the 3. We're guessing and checking here. And so if that's a 3 below, this is definitely a 4 above. And the fourth root would be 4 times 4 is 16. And what's 16 times 4? 64. And so we're really close to the 3. So we're probably like 3.1 or 3.2. Okay, good. So now we can kind of estimate where to put these. Oh, cube root of 70. So cube root of 70. So we know cube root of 64. That's a perfect cube. We just finished doing that one. That one's 4. So then what's this got to be? This has got to be 125. Now we're really close to the 4, so we're probably thinking like 4.1. So we have, this one also is going to be about, we already did this one, root 32. That was going to be about, what was it? 5.7. Okay, so we got 1.3 over here, then we got 4 and 7. So let's say this is 1, 2, 3, 4, 5, 6, 7. Good. Let's put the very first one on there. So 5.7 and 5.7. That's going to be just a little bit above 5.5. So that would be A and C. Then which one should we do next? Let's do this one, 4.1. That's going to be just a little bit more here. So that was B, cube root 70. 3.2, this one right here, that's going to be a little bit more than 3 right there. So that's going to be cube root 30, which is D. And then this last one here is 1.3. So that's going to be a little bit more than 1. And that's going to be E. And have we placed them all? We've placed 5. There are 5. Good. So now in your calculator, let's see. So 2 root 8. 2 root 8 equals root 32. On the calculator, you can also go 2 times root 8. Okay, so on my calculator, I'm going to do that. 2 times 8 square root. I haven't done the multiplication yet. Got to press equals 5.65. Okay, so not bad. I got 5.7. That's pretty darn good if you ask me. All right, then let's go cube root 70. Cube root 70 on the calculator. So don't use your cheating button. Use the one that is the, so yeah, this one right here that does all of them. So for me, I go 70 and then my index. Some people have to hit their index first, 4.1. Again, this is another calculator check. So if you don't want to do it, that's fine. You're just not going to learn how. Cube root 30, again, don't use your cheat button. Use the one where you use the index for anything. 3.1, so cube root 30 equals 3.1. Not bad at 3.2.